All right, welcome back, everybody. We are going to go into our last event of the day, which is a faculty panel. It's an idea that our advisory board came up with. They thought that as part of McClure School Day, maybe it would make sense for some of the faculty to talk about their areas of expertise and kind of do this more of a two-way sharing event. And so this was planned to be that, and we will still do this. Before I switch to the panel and we'll go through our presentations again, we're on Twitch and Facebook, but only on we're only monitoring the Twitch chat for questions. So type your questions in there, and we'll try to get to them. And so I do want to do a couple of shout outs here before we get started into this last session. First of all, a huge thanks to my colleagues, to Doug Bowie, to Julio Rouse, to Brandon Saunders, who worked on a whole lot of the tech that I'm using here to host this event. This is not, I'm pushing the buttons, but they did a lot of the setup, and it's a lot of good fun stuff and things that we will do again in the future. But I'm really grateful that for the work they did. Also want to again shout out Adam and Max, who've been our Twitch moderators and been kind of watching over the chat for me. Very much appreciate their work, as well as our PR team. I sort of caught glimpses on my phone about tweets going out about the various talks, and again, yeah, very much appreciate it. So thanks to everyone for the work and getting this put together, and thank you everyone who's here and watching us. These are crazy times, and I'm glad we can connect in this technological way until hopefully a relatively near future when we can bring all of you back to campus and the way we love. But what we learned here may give us the opportunity to have events like this casually sometime in the future, and that's a good thing. So with that, let me switch over. What did we do?
Whomever's testing, can you hear me but not Hans? Okay. How about me? Can you guys hear me?
Okay, let's see. I should be back now. We could hear Brandon, they said. Yep.
Cool.
Looks like we're back.
Great. Yep.
Okay. Looks like we're back. So with that, we'll let Brandon take over here. And
Okay. And I think everybody should say a big thanks to doctors. Excellent leadership, and thank you for being the production central for the sort of fun. It's been good to watch. So I'm going to give you kind of my take on software-defined X. Primarily networking, but there's a lot of software-defined things in this world. Usually, I'll start off my lectures with some sort of kind of bad joke, probably something about dogs playing poker, although that's an inside joke. We'll leave it there. Instead, I'm going to have to start today, since I don't have anybody to roll their eyes at me, an analogy. So to kind of bring together SDN and be able to take it apart in a way that we can understand. Let's take a look at our base runner as a packet in our network, our base and our base coach as the forwarding engine for our network. And then we have our head coach sitting off in the bullpen someplace. They're going to function as an element that we're going to refer to as our controller. So a lot of architectures for networking equipment actually follow this, have some sort of forwarding engine component buried inside, and then some component inside of the box that's controller. So the big difference with SDN is we're going to take that notion of a controller and we're going to rip it out of the box that's going to actually forward packets, and we're going to move it someplace else to some other device located on our network, and actually have two devices. One that's just there purely moving packets from port 1 to port 5, and it's waiting for this outside controller to send in instructions for, hey, here's this new flow. We want you to forward packets that look like this from port 3 to port 6. So there's a very distinct separation in responsibilities. Now, one of the advantages to this environment is that we can kind of gather all of these forwarding engines under one controller. So kind of one controller rule them all. At which point in time, the possibilities become endless. If you have a rack of computer equipment, let's say you have 40 or 50 computers inside of that compute equipment, and each one of those might have hundreds of virtual machines, et cetera, running on it. But the top of that rack is probably going to have some sort of physical switch associated with it, a top of the rack switch. And you might have 20 of those racks in a row, and you might have 20 rows. You get this wildly complex switching environment or network environment. It wouldn't necessarily have to be purely switching. But you have this complex networking environment, and having that opportunity to have one controller managing the flow of information across this entire data center it creates some really exciting possibilities for us. Additionally, because of the adoption of cloud architectures and virtual machines and that kind of stuff, a lot of switching and network moving around of packets is actually happening inside of a virtual world these days. And these systems can operate as standard standalone switches, but they also are all very prone to be plugged into a larger SDN or software-defined networking environment. One, because there's a clear acknowledgement that there's a lot more dynamicism going on in that network. So I want to take a look at the controller first. Terms, or a lot of the previous slides were about the forwarding engines. Once we look at the controllers themselves, the marketplace for controllers is went through a period of expansion. There were a lot of controller software stacks that were developed as open source software. A number of the best ones of those have been picked up by larger commercial companies, and they have this kind of part open, part closed functionality to them. But all of them have the commonality to them of both what is referred to as a southbound interface and a northbound interface. In the southbound interfaces, this is the logical connection between the controller and all of the forwarding engines that are in the responsibility of that controller. Now, this interface or this interconnection is sometimes a vendor-specific API. More likely, there's an open version of a southbound interface called OpenFlow, and it's a very common implementation. It allows for interoperability between different forwarding engine manufacturers as well as different controller suites as well. So that's a southbound interface. The other interface that's going to happen very often in these controllers is a northbound interface. So this is the southbound interface, and I needed to update my presentation in this one here. The southbound interface is more about like the communication between the head coach and the base coach. The northbound interface would be more like the communication between the head coach and say the team owner. The team owner is going to come in and say, hey, I want you to win the next 5 games on the road or something like that. And then the head coach has got to give the instructions out to the base coaches and the players to make that sort of thing happen. But these northbound interfaces have a lot more variety associated with them. They're just APIs. So in any sort of scripting or software developer could modify these or make them do what they want. But these are places where we're going to see integrations with other network management or IP address management engines, security systems. You might integrate it with your service and support. You might want to be able to have a support phone call come in, and the support technician is there and is able to actually do live inspection, or maybe a salesperson needs to be able to deploy a new service. All of that stuff would be an integration between that user's portal to their work and the controller. And you're expecting the controller to carry that on, those instructions further on. The other term that you'll run into very often when you start talking about software-defined networking is network function virtualization. So a lot of networking is kind of focused on switching and routing, but there are other networking functions at higher layers, firewalls and load balancers, key examples, and then other applications. Well, inside a software-defined networking environment, it becomes very possible to actually bring those applications in and actually implement them as part of the controller software itself. So rather than having a dedicated device for, say, a firewall or a load balancer, it's just inherently done as part of the software, and you get the flexibility of software when you do that. So let's take a couple look at applications of software-defined networking. So one of the nice things about SDN is this notion that we really want to be hands-off. Part of the problem is that deploying, say, artisanal network or infrastructure is something that I have a passion for doing, actually. So you're at a command line. You're actually grinding through configurations. You're applying IP addresses. You may just lay out large networks and get them up and going. The reality is that those things are, humans are involved and we're prone to errors. It's also extraordinarily slow. And a lot of the rest of the service deployment that we'll see in our IT world is moving towards kind of rapid micro deployment models, things like DevOps, Kubernetes, Docker. There's a whole encyclopedia or dictionary of terms that we can have in there. But these systems are moving entirely too fast, or they can be deployed at a speed that hand managing the underlying network, it's just not practical at all, driving a huge need for the network to be able to be integrated into these environments. And not only are we defining in software the applications themselves, but the underlying networking that has to occur to make those systems deployable. Now, these deployment opportunities actually create a different underlying reason for software-defined networking. These massively scalable environments, we very quickly run into what we're going to refer to as hyperscale infrastructure. So things like Facebook, Amazon, Google, Microsoft, they're deploying massive amounts of hardware. And kind of as an aside, they need to be able to deploy that stuff in a very repeatable fashion. So they're looking at things like white box hardware, open source hardware, so that they can buy these environments from multiple manufacturers. But they also like this notion of open source network firmware, which has a lot of interaction with software-defined networking, so that these systems can create these wildly dynamic, wildly virtualized environments. So in those environments, in the data centers for those environments, we're creating new and more complex network architectures. If we look at kind of traditional access aggregation core architectures, we run into scalability issues. You might have this access layer with 10 edge switches in it, but if they're coming back to 1 or 2 aggregation switches leading into one router, but you have a lot of traffic that's going in between the points in the access network. For example, you have 2 virtual machines in racks on opposite sides of the data center, you have a scalability issue. There's this, you're limited by the amount of traffic you can put through an aggregation layer. So a new architecture that's coming about is the notion of a spine. And in this case, you'll have massive horizontal interconnectivity between these lower portions of the network, where if you mapped out the wires themselves, would have some kind of notion of the complexity that you would see inside of the human spine. The problem is our traditional network architectures, things that do loop mitigation and other controls of the network, aren't designed or can't easily handle the complexity of that architecture. And if you bring SDN in and you're looking at all of the devices on that spine as a single unit, rather than a bunch of independent operating units that have to figure out largely by chance on how to take loops out, SDN steps in and says, hey, okay, everybody, we're going to draw the most efficient routes and reuse as much bandwidth as we possibly can. And we really don't care about loops because no packet is going to go through the network in a way that wasn't already planned out. So we get SDN as a good application for that sort of spine infrastructure, or the massive horizontal internet or network connectivity, hence the bridge analogy. So if we take SDN outside the data center, there's a couple of market changes that are really driving the adoption of SDN outside the data center. This is mostly inside of the concept of SD-WAN, which we'll look at next. But we're seeing very dramatic drops in the cost of dedicated internet access, as well as kind of an averaging or maintaining of the costs of dedicated point-to-point circuits from our telco providers. So the circuits are becoming significantly more expensive compared to our dedicated internet, but they're also come with their own complexities. So we have to have more knowledge about how to manage those and interconnect those systems. So what we would really like to be able to have is ability to spread this out. At the same time, we're seeing a lot of drive for cloud computing, especially for office productivity tools and web-based applications. So these are really changing our traffic patterns. If we have a multi-site organization, you might have a home office and a bunch of branch offices. And before the kind of cloud productivity tools, you might have a lot of traffic going back to central file servers in your central location. Not so much anymore. Most of your traffic is probably headed to the internet to begin with. So bringing all that traffic from these branch offices back to a central office just to pass them back out on the internet is inefficient, and we'd like to be able to get rid of some of those inefficiencies. Then you make working from home or working on the road, what you be doing these days, maybe we'll just call it work some days, but you create an oddity in how we actually view our networks. There would have been a day and time in traditional networking that you had a very solid network perimeter, your network border. You had this router sitting in a rack someplace, and you knew that everything on the other side of that plug was the internet. Everything on the other side of another plug was everything internal, and that's not so much true anymore. Largely today, if you could find what you could call a network perimeter, it's probably a mirage, or it's not going to be there much longer, especially after everybody working from home. So we have these multi-site organizations. It's not just the home office and branch office. You have your IT environment that you might have in-house, but you also may have a cloud environment that needs to be interconnected to the system, or people working from home, or co-located data centers. Being able to bring all of these things together in a way that creates this kind of virtual network perimeter. SD or software-defined technologies, especially as they are applied to appliances or networking equipment at the very edges of each one of these locations, if we can treat all of those systems as one, managed under one umbrella, and with a little bit of encryption and a little bit of tunneling in between them, which they can set up themselves since they're all going to be managed under one controller, gives us the impression, at least from a virtual perspective, that we have a network border. We have some place where we can enforce policy. Fortunately, at the same time, we can go back the other direction. Maybe not all policy is enforced at a network border. Maybe you need to enforce it further down. Maybe we need to be able to keep everybody that's in accounting away from everybody inside of engineering. But we can do this at a much more granular level because the network, again, has that sort of external controller associated with it. The 5G, our newest cellular technology, the underpinnings of that are heavily dependent upon software-defined networking. The notion that we might go to a wireless service provider and say, hey, I don't want to set up my own wireless network. I'm going to take a slice. I'm going to buy a slice of your network, some sort of maybe automotive system. We need to keep all of these cars interconnected with each other. So you'll go to a provider and say, hey, I want a slice of this function. But it's only because we have software-defined networking at its core or designed into the core of that system to begin with, is that even possibility, and the ability to deploy that, maintain it, is a wildly changing environment. And it's just not something that we could have the artisanal sort of deployment nature. So the software-defined networking is really a key element here. That leads, that's all based upon some open technologies. There's Open RAN is just kind of a term floating around in here. If you're familiar with 5G stuff, that'll make more sense. But we enter that function actually brings up some interesting opportunities for us. We have since the 5G technologies are all virtualized and software defined, we get this notion that at the base of every cell phone tower could very soon be basically a small data center, a small distributed data center. And when resources out at that in that little micro data center aren't used for the 5G technologies itself, it may lead us to the opportunity to have edge computing, especially if we're interested in real-time, low latency things like gaming or operating robots or driving cars. All that stuff is very, very latency sensitive, and latency is going to be kind of the next theme that we need to be taking a look at or being conscious of as technologists. So these are kind of some opportunities. The systems that might live in those things have to have connections upstream. That's all going to also be software defined depending upon how those organizations interconnect stuff. So there's some opportunities inside of software defined networking. We're kind of scratching down into each one of those as in various classes and starting to see how they integrate into kind of the core of the teaching that we do. Here's some ways to get a hold of me. You're probably more likely to get me on email than anything, but you can catch up with me on other places.
Thanks, Brandon. Just trying to take a look and see if there are any questions now. We can address them, or else we can also, of course, come back at the end of the panel and answer some more questions. I don't see anything in chat right now, so maybe we can switch over to Chip's sharing his screen, and we'll go from there.
Okay, I think I'm ready when you guys are. Can you hear me?
Let's check with our chat here. I think you're coming through. Someone on chat, can we hear Chip? Yep, we're good.
Super. Okay, so I thought what I would do today is just lay out a few definitions. I think my sense is that people are increasingly, just as laypersons, able to parse the differences between AR and VR and MR. A few years ago, that wasn't the case, but I am going to spend just a couple minutes kind of laying out the differences among these different types of realities. And then I'm going to look a little bit at some of the contemporary tech stuff that's pretty hot and exciting and successful, and some things that are maybe not quite as successful. And then I'm going to talk briefly about some of the congruences, the areas of shared interest between the two halves of the McClure School, which to some people I think should also be pretty obvious in terms of why we would use networks in VR and AR, why these things would matter. But I'm going to talk very specifically about a couple of those things, including the Internet of Things, and then there'll be a brief mention of a pandemic-related use of these technologies, which has just cropped up very recently. That is both very interesting and current, and also, of course, somewhat tragic. Anyway, XR industry tech trends and trials, and I'm Chip. So this is something you'll see a lot if you start to dig into any kind of academic or scholarly accounts of VR. This is way back from 1994 in a widely cited, as in like 4,000 times, paper by Milgram and Kashino. And this is Gerald's, who wrote the textbook that we use in our intro VR class. This is his interpretation of it from 2016, but it's very, very similar to what Milgram and Kashino originally published. And then people are starting to argue about this a little more these days, whether or not we need to reevaluate this. But basically, what you all are looking at here is the real environment. This is called the virtuality continuum. And this helps us understand the differences between augmented reality, virtual reality, the real reality, and so on. And then we've got some places where those lines tend to get a bit fuzzy. There's some slippages in there. And I'll talk about that in a second as well. So on the far left side of the screen, you've got the really real world that is allegedly unmediated, or at least not including any digital elements for the most part. That's the physical, fleshy world that we all inhabit for the most part on a day-to-day basis, without getting too metaphysical here. And then as you start to add digital elements to that world using any variety of interfaces, we enter the realm of mixed reality. And you can see that bracket there at the top. Mixed reality includes everything in between the real world, which is not part of mixed reality, and the fully virtual world, which is also not part of mixed reality. So briefly, virtual reality then is an entirely computer-generated reality that's interactive and basically hijacks the senses in order to give you a digitally created world that you can live in, move in, interact in, and so on. And we need usually a head-mounted display for that. There's also something called a world-mounted display, but head-mounted displays are by far the most popular, and some kind of controllers, motion tracking, and so on. Augmented reality, I think most people are, again, familiar with this now, because the easiest, cheapest, and simplest way to access augmented reality is through a relatively recent smartphone. So most smartphones are capable of acting as an interface for augmented reality. And basically, augmented reality, in contrast to virtual reality, is when we're still in connection with the real world, with this real environment, but we overlay digital elements on top of it. And those digital elements are aware sometimes of the real world and able to interact with it and interact with us. And other times they're kind of just put on top of it without an understanding of the real world. Then we move into augmented virtuality. And this is much less common, but it's becoming more and more prominent in certain applications. This is where you're largely having an experience in the virtual world, but it is augmented or enhanced by the real world. So basically, we go from one end of the completely non-digital world all the way to the other end, the completely digital world, which is VR, and everywhere in between. And as we move closer and closer to VR, it becomes less and less the real world, more and more the virtual world. I'll talk about why that's important briefly in a second. So then there's XR, and this is kind of a buzzword that basically means any and all of those realities, except for the really real world itself. And XR means cross reality or extended reality or exponential reality. And basically, that X functions like an unknown, like an algebra. Because what we're admitting here, and somewhat it's an industry marketing term, and at other times you'll see a bunch of academics use these words and tech companies use these words. It does mean something. It basically means that whatever we're working with combines elements of augmented reality or augmented virtuality or virtual reality, puts those together so that those lines become blurry and that we're not exactly sure which reality we're talking about. We know it's digital, we know there are elements of the real world in there, but we're not necessarily ready to settle on a particular term or acronym. We're not ready to commit to say, this is VR, this is AR, because it's some of both. I think we're going to see this more and more as these applications become increasingly widespread and widely adopted. So it's kind of a catch-all term in addition to being a marketing and buzzword that just means that the lines among and between those realities, whether it's AR, AV, VR, those get blurred. And it also means that it can include any or all types of those. So the way that I'll be using it in our conversation today is that XR is a shorthand for any of that stuff. So when I talk about the XR field, that allows me to say AR, VR, MR, and not have to be very specific, because if I say VR, that obviously means something rather different than AR. XR can mean any of those things. So now the gear and tech portion of the talk. This is for folks who are into this stuff. I'm not going to cover even a tiny fraction of all the things that are out there right now. I've chosen these particular systems for very particular reasons. So don't be like, oh, why did he leave out Nintendo? Or why didn't he mention the Samsung Odyssey? That's what they use in the XR lab at the Grid Lab. This is not a survey of all the different things. This is just a few different things that I want to point out in the industry that are happening now that are important. So this is the Valve Index, and the Valve Index was recently released. It costs about $1,000. It's significant for a number of reasons, because it's Valve's first virtual reality system on their own, without collaboration with anyone else. You can see to the left and the right of the head-mounted display, it uses external trackers, a lighthouse system. So that means it's tracking your motion from outside, which can be very accurate, but also requires a lot of space and proper setup and so on. But I'm acutely interested in this today because of these controllers. And these are often colloquially called the knuckles controllers, because they go over your hand and are supposed to be more intuitive. Because one of the things we've been trying to solve in VR generally, and by we, I mean everybody who plays it and is excited about it and works with it, wants the ability to manipulate virtual objects in a more naturalistic way. And for most systems, we're either stuck with no controllers at all, which can be pretty cool, but also problematic in terms of very kind of discrete movements. Or we're stuck with glorified video game controllers, which these still are somewhat. But people are really jazzed about these controllers. So it's also a great headset. And Valve, as you'll hear in a minute, recently came out with probably the greatest virtual reality game in history, such as it is, Half-Life Alyx. So it's also interesting for that reason, because Valve, along with Oculus, are really kind of pushing the envelope here. But these controllers slip over the hands, and if you let go of them, they stay there. So the idea is that your brain quickly adapts to the idea that they're not controllers, which is the idea of VR controllers generally, but that's a goal that's seldom achieved. So the Valve Index. This is the Oculus Quest. And the Quest not only is rather affordable compared to a lot of other VR systems like the Valve Index, but it's entirely self-contained. So it uses inside-out tracking. Recall the lighthouses, which are the external trackers on the previous slide. This uses inside-out tracking, which means that the tracking is coming from the cameras that are on the front of the device. You don't need a computer for this. There's no tether. The tether is just a fancy word for cable, right? Most of these headsets, including the Index, are tethered to a PC. That's a problem because you get tangled up in that tether. The cable is only so long. It limits your movement. You drag your computer across the room. You get twisted up. You fall. It wraps around your neck. It impedes your movement, right? So we like not having tethers, but the advantage of having a tether is that you have the processing power of the computer. So with a self-contained headset like the Oculus Quest, everything's there. You can't play Half-Life Alyx on the Oculus Quest, really, because the processing power isn't there. But I and many other people are super excited about the Quest because that's all you really need. You don't need a computer to run this, and you can set it up anywhere. I throw it in a bag, go to my buddy's house, and you set up your boundary right there. We're talking about $400 or so for the entire system, which is making it more and more accessible to a lot of folks. And it's a very exciting device. I mean, it's better than a lot of the tethered systems that we were using just a few short years ago. So I really think that this is super promising, and I bring it up for those reasons, but also because I think that we're going to see more and more of this. I think we're going to see the devices becoming increasingly self-contained and portable. All right, so on to AR and MR. We've talked about the definition, so I won't belabor that, but this is the HoloLens 2. It's an augmented and mixed reality device from Microsoft. Obviously, there was a HoloLens 1. GridLab has a couple of those, and we've ordered the HoloLens 2, just kind of waiting on Microsoft and the Ohio University to come to some terms. That's neither here nor there. But basically, this device, super powerful, entirely self-contained, not tethered, but it costs $3,500. So it's not really a consumer device, and really you need developer credentials to get it anyway. Educational credentials, developer credentials, an industry connection, something like that. It's not a device that you just buy to play games on, but it's increasingly used in industry and education and training. And it shows a lot of promise. And again, as an AR and MR device, it's not going to block out the real world completely. It's overlaying digital elements onto the real world. So you're connected to the fleshy physical world while also seeing elements of the virtual world. This is so exciting for industry and education and healthcare that the United States military just bought $500 million of these things. $500 million from the US military. No, I don't know exactly what their plans are for the device. You can use your imagination, but the idea then is much like you see here, that you can do live video chat, you can do computer vision. The person on the other end can see through the cameras what you're doing, so they can tell you, say, how to fix an engine. Of course, it's used for gaming. Those possibilities are there for education and so on. But this is being used in high-end manufacturing right now, in healthcare right now. And this is in part to say that augmented and mixed reality, in addition to being easily accessible through a phone, has this other high-end sector where people are starting to figure out that they want this, that this gives them something that no other technology is able to give them. Similarly, Magic Leap 1, a cautionary tale. AR, MR, it's semi-tethered. I say that because you can see in the background there is a cable, and that cable actually goes to this little pack here that fits in your pocket or clips on your belt. So you're tethered to something, but that something is something that you can keep on you. You do not need an external computer to run this. The processing is going to happen in that little packet in the headset. But you do still have a cable that could be a little bit annoying, but doesn't have the same problems as most tethered headsets. Again, AR and MR, lots of hype surrounding Magic Leap. Many years they were, well, as far as it goes, several years they were the subject of a lot of venture capital. Got something on the order of $2+ billion invested for people like Google and Alibaba. AT&T, toward the end of those investment runs, became a special partner, and so you can buy these things at AT&T stores. They're cheaper than these were supposed to be consumer devices. I say supposed to be because they sold something like 6,000 units instead of the 100,000 that they expected to ship. So really, really a major failure commercially. We have a few of these in the Grid Lab. They come in 2 sizes. That's why we have 2. Isn't that sneaky of Magic Leap to make 2 different sizes? The HoloLens is one size fits most. Magic Leap comes in a big and a small. But in any case, those are a little bit cheaper, except if you have to buy 2 of them, than the HoloLens. They're in the $2,300 range, depending on if you buy the maintenance plan. And they're neat. They are. Palmer Luckey, who created the Oculus Rift and really got the ball rolling on all this stuff, did a very interesting kind of examination where he pulls the whole thing apart. You can find this online if you're interested. But it didn't happen as a consumer device, a very expensive consumer device. So Magic Leap is recently rebranding themselves and pitching this to businesses and education, really, I think, to see if they can get rid of some of their inventory. But it is a cool device, not nearly as cool as the HoloLens. In fact, a few colleagues at the Grid Lab had a call from Magic Leap where the Magic Leap folks were going to talk to them about some exciting projects, and it just turned into a complete sales call. But an exciting device nonetheless. AR, MR, pretty cool. If you're around OU, come to the Grid Lab and check it out once we all start, being able to be around each other again. This is Valve's Half-Life Alyx. Came out about 3 weeks ago, I think. 3rd week of March. And the reason I bring this up is A, because it's Valve, B, because it's Half-Life, but most importantly, C, because I think this is the greatest VR game ever made. The reviews are stellar. The sales numbers, we will find out soon, but they're bound to be impressive. There's a lot of Twitch streaming surrounding this, and it is a sequel, so to speak, to Half-Life 1 and 2, not the sequel probably that all the Half-Life Uber fans were hoping for, but by all accounts, a really incredible game. So the question is, does this get people to buy VR headsets just to play this game? And it looks as though the answer is yes. So VR has been used for a lot of different things, but it still hasn't quite cracked the gaming market in the way that a lot of us had hoped. And I think this game probably is an entree into what the next generation of virtual reality gaming can be, to say nothing of using VR for education like we do in the Grid Lab, for healthcare like we do in the Grid Lab, for training, and on and on. So what else? What else is going to happen soon? The question is AR glasses everywhere. I've told you that most of us are able to access some rudimentary AR, whether it's Snapchat filters or Pokemon Go, or the tape measure in Apple's iOS, or Amazon. Amazon has augmented reality features where you can look at a bookshelf and change the size of it and place it in your room with your phone camera as the interface, and so on. We know that Apple and Facebook have been working on augmented reality headset glasses, something that look a lot more like what I'm wearing right now, most likely using a phone to do the processing so that you're untethered, with the hope, I believe, that people will just walk around using AR all the time, the same way that we all walk around with smartphones these days. Facebook has admitted this a number of times that they're doing it. And if you really want to have your mind blown, and you've seen Christopher Nolan's Dark Knight, you should check out Facebook's plans for live mapping, where they mine all your data and all the images that the world has given them in order to recreate the world virtually for their AR glasses. I digress. Facebook is racing to do this. Apple is racing to do this. We keep wondering every year when Apple announces their new iPhone, if this is the year that they come out with the glasses, because they have a pile of patents related to this stuff. And if you dig deeply enough into the iOS, the operating system, you'll find the augmented reality glasses features hidden in there. So this stuff is coming, and Apple has been very, very slow to pick up on VR. And this is probably one of the reasons is they're putting a lot of their eggs in the AR basket. And Facebook, of course, owns Oculus. They make the Quest. They make the Rift. They make a lot of the software that enables hosting of spatial audio, 360 video, 3D photographs, and so on. Facebook is one of the prime movers in the AR and VR industry, pumping tons of money into it. Lots happening there. Getting toward the end here, this is basically the front matter of conference panels that were held in 2018, the Association of Computing Machinery. And I'm showing you all this because these panels were called VR AR Network. And this is, again, a couple years ago in the summer of 2018. But basically, all of the papers on this panel are geared around how we can use and optimize networks for virtual and augmented reality. So this is the McClure School in a nutshell, the unique combination of grid and the network side of McClure. But all these papers, and I can pass these along if anybody's interested, deal with things like predictive view generation, smart streaming of 360-degree video, cinematic VR, network optimization, and network responsiveness for streaming VR. Really exciting stuff. More and more technical papers for sure, but more and more thought is being put into this. How do we stream VR? How do we stream AR? What kind of networks are we going to need in order for everybody to walk around with AR glasses on our faces? A little bit more industry specific, just to seal the deal here, XR job growth, and this is just for software engineers. So we're not talking about 3D modelers, we're not talking about 3D artists, we're not talking about people who do lighting, spatial audio folks, which is my wheelhouse. We're not talking about any of that. We're only talking about software engineers. And this is growth in company interview requests for software engineers. You can see that this blows everything else out of the water, even gaming. Between 2018 and 2019, AR and VR interview requests just for software engineers went up 1,400%, 1,400% in a year. So it's an exciting time for this kind of stuff. And again, I think those numbers are only going to be more impressive as we go along and put some of those other careers in there outside of just software engineers. Finally, and no kidding, this is, it's crises provide a lot of pain, a lot of sadness, a lot of uncertainty. But of course, they provide opportunities for some people who want to make money, sure, but also who are attempting to solve problems using technology. And I don't just mean, testing for coronavirus, but this is, well, no value judgments. Let's just talk about what this is. Rokid is it's a Chinese startup company with offices in the Bay Area, and they make augmented reality glasses. This is a brand new attachment for their augmented reality glasses. Rokid has, again, Chinese company, but it has a lot of big time partners, a lot of money flowing into the company as a startup. Alibaba, Daimler, massive corporations like that. Basically, what you're looking at is their AR glasses with an infrared heat sensing camera on the side. And that's just an that's a peripheral that you can just plug in. You don't have to buy that with the glasses. You plug in their their peripheral, and you stick it there on the side, hooks up via USB to your AR glasses. And again, this device would be similar to Magic Leap, not the camera, but the glasses themselves, similar to Magic Leap, similar to the HoloLens, not commercially available yet. And what they're doing with this camera is, no kidding, they're sensing whether or not someone has an elevated body temperature. And this would tell you if they are running a fever. It can do up to 200 people at a time. And they envision this as something for healthcare professionals, something probably for like the state for surveillance, something for like airlines, cruise ships, those kinds of things, but also for individual users. If you're having to get used to a new normal where everyone is constantly concerned with catching a deadly virus, perhaps you're avoiding people who, have a fever for other reasons. But in any case, that's what they're doing here. It's augmented reality. You still see the real world. You're walking around in the real world, but you're also able to access this data of who has an elevated body temperature. Do with that information what you will. They've also advertised it as having Internet of Things capabilities, where you would be able to send this data over the network back to a database where someone would potentially be able to store all that information that you're sending. So it looks like this. The real world at the bottom left, your heat data at in the main area of the screen, and then on the right, your augmented reality data, which also could become IoT data that you're sending back to a database that catalogs all this stuff and preserves it for whatever use. You can see your augmented reality, temperature readings, and so on. It's a brave new world. Thanks a lot.
Chip, we had a couple of questions. One of them
Sure.
had to do with OpenXR and kind of your take on whether there'll be a take up by vendors other than Microsoft, from what you can see.
I don't know. I see John Bowditch, director of the Grid Lab, hopping up on there, and I tend to agree with him that yeah, I don't see any kind of standardization happening immediately. I've actually seen a lot of just sort of amateur use of some browser-based VR and AR programming. I've been working with a graduate student on some of these applications, but yeah, I mean, I'm not a developer myself. Obviously, I keep track of this kind of stuff and tinker, but I don't have a feeling that this sort of thing is steamrolling anything else at this time.
Yeah. The other question, if you've seen the chat, you probably saw it was more more of a comment, I guess. But just the question of form factors. Are we going to get to a point where the headsets are maybe a little bit more of a comfortable form factor than what we're dealing with now?
I think that's a fantastic point. I think it's one of the main stumbling blocks of VR. Like, we don't want to look like we're piloting the USS Enterprise when we're walking around outside. And I don't just mean in fashion sense, but also in the sense that stuff gets heavy and cumbersome and feels weird and sweaty. Battery life is going to be another issue too. I wear my glasses for 12 plus hours a day. I don't think I'm going to wear something that is actually a screen an inch and a half from my eyes for 12 hours a day. That's another problem. But yeah, form factor is a big issue. We're getting closer. I mean, if you go back to that slide, well, you can't go back to the slide, but if you recall the last device, it looks like a kind of awkward pair of sunglasses, that Rokid headset. I think we want that more, and that's probably going to be more achievable, more streamlined form factor for AR before VR, simply because of less processing that's happening.
And obviously the question popped up with those glasses you showed about the privacy issues and whether they're being addressed. And of course, we sort of had a foray of that with Google Glass already. So again, I don't know what your take is on that.
Oh, well, I mean, I have a lot of takes, but I don't want to take up the rest of our time. We got to actually let you talk today too, Professor Crusoe. But I'll tell you right now, Zuckerberg, this is not a secret. This is not conjecture on my part. The business model of Facebook is to make money off your personal data. Zuckerberg sees augmented and virtual reality as the next big place to gather your data. That's a absolutely established fact. So check the terms and conditions.
Yeah.
There are huge privacy issues. Google Glass, that's another one. I mean, look, how many of us are really going to feel comfortable going around checking everybody's temperature? Like when they're like, oh, Hans, are you feeling okay? I see that you're at 98.9 today. Like if you coughed or sneezed. Again, as Jim Gay very poignantly and humorously says, we are getting used to wearing masks now. But yeah, privacy is going to be a massive thing. The more we adopt these technologies, the bigger an issue it's obviously going to be. And look, anytime Facebook is involved,
Yeah.
buckle up.
Okay. Thanks, Chip. And so, I'll get the task here of wrapping up. So let me get myself set up. There we go. And so I have the task of talking about esports a bit. And first, a disclaimer: my expertise, my personal expertise, is not so much in the business side of esport. We have folks that know how to do that. We have a whole gaming summit on the business side of esport. So I'm really more interested in kind of the environment that exists in the games, the technology, things that are of interest to our school. And I couldn't help, but I can't help but pull a few numbers out. So you can see one of the, I pulled out an image of one of the Dota 2 tournaments that took place in person in a large arena, and I think I brought it up because it has a lot of similarities to the arena-based events, basketball, whatever. And so I had to bring up some numbers. So I went and looked up the biggest prize pool that have been recorded for last year. This year's tournaments, of course, who knows what's going to happen with those. The two largest tournaments were a Dota 2 tournament with a $34 million overall prize pool, and Fortnite tournament, which actually got a lot of USA Today press because the winner was, didn't even have a driver's license yet. That was a $30 million tournament, overall prize pool. Interesting enough, even though Dota 2 and Fortnite have the largest monetary prize pools, the biggest viewership is actually League of Legends, which is super popular, especially in Asia. But it doesn't command anywhere near the prize pools that the other games do. But they recorded in the last in one of their 2019 one of their premier tournaments. Overall, for the tournament as a whole, 137 million viewer hours, which is pretty good, and 3.9 million viewers for one of the more heavily watched games, the semifinal in that case. And I pulled up the numbers, and I think where those tournaments of esport is from these numbers, it puts it roughly on par with Wimbledon. The Wimbledon prize pool was 49 million, so it's coming close to that. And some of the viewership numbers are also relatively similar to those. So one of the things that I found kind of interesting, and then that that I want to sort of point out. There are a whole bunch of different game styles. I mean, Dota 2, League of Legends are kind of the arena 5v5 games where you control an avatar with certain capabilities. Fortnite, which is up on the top top right here, is essentially a first-person shooter. It's either one against many or small teams, the two of four, I think. Team competition is basically just kind of a last man standing kind of game. Um, CS:GO is again a team-based first-person shooter on a very small map. But then, there are also card games. I've got an image here of Hearthstone. And there are various other competitive, basic card games. If any of you, or I know my kids did. I didn't play the actual physical Magic the Gathering card games. This is the electronic version of that. And all of these have competitive leagues. By the way, Ohio University has a League of Legends team. We also have a Smash Brothers team. I don't have an image of that, but there are a variety of different game styles that have been adapted for esport. So what's driven from a game perspective, what's driven the ability to even do esport and at any level is that, first of all, obviously they have to be multiplayer games, which is not a terribly recent development, but it's obviously at this point it's very, very rare to see any games that are not multiplayer. And the VR games like Alex are still single player. But many, many games today, and even ones that are single player story games, also have a multiplayer mode. And so that was one of the driving factors, of course. Um, I brought up, this is a screenshot from a game called Dota Underlords. Uh, Different, again, a somewhat different game mechanic, but I brought it up because one of the things that a lot of these games started doing is to allow you to create what's called a custom lobby. You can see on the screen there's a code. If you don't have that code, you can't join me. So I can go. In this case, this is a game with 8 participants that compete with each other. So I can contact my 7 friends and give them the code, and we can all join. So you're not necessarily playing with random players, but you now have the ability to set up games with the people you want to either play with cooperatively or play against in a competition. And that's a necessary game mechanic to be able to do esport, right? So you have to be able to bring up a lobby, invite the teams, give them the codes to get into the lobby, and arrange the game. And more and more games that want to play a role in esport are building in the game mechanics to create these custom lobbies to make that happen. Uh, and Dota Underlords is an interesting example because it's a game that is not super pop. It's fun. I played myself, and it has a good following, but it's not like super popular. Um, but there are tournaments that are basically arranged by private individuals. They have like a $50 prize pool. I mean, these are basically, think of basketball pickup games in the neighborhood. But it's very easy for someone to go on Discord and say, hey, I'm going to put a tournament together next Thursday. Here's a way to register, and then they create these custom lobbies and people play. And they keep track of, just like you would in a neighborhood tournament, you keep track of the brackets and who's moving on to the next round and that sort of thing. So the games have to have the mechanics built in to make this happen, and then more and more games do, with the hope that maybe they'll become one of the next big hits in esport. So I talked about the custom lobby setup. There are a number of other things that have to happen for esport to be fun. Right? The multiplayer games in general suffer from cheating. I've never understood why people cheat. By the way, people cheat on single player games too, which I can't understand. That doesn't make any sense to me. But people do that too. But it doesn't matter, right? If you find some sort of a cheat code and you give yourself infinite power in a single player game, that makes you happy, no problem. But But in a multiplayer game, if somebody's cheating, they can see through walls or whatever silliness they come up with. Then not only is the game not fun, but it's also not a fair esport event. And so there's literally an industry of software companies that do nothing but provide anti-cheat services to game developers. And it's as you might imagine, it's a cat and mouse game. There are also very well organized e-commerce sites that will sell you cheats that work and work in spite of the anti-cheat systems, and then that customer complains because the anti-cheat system caught up with them and they got kicked out, and now they're mad at the vendor who sold them a cheat. And it's a weird place. But to run an esport event successfully, the publisher of the game has to constantly update and maintain their anti-cheat systems. Um, Obviously, the game has to be skill based in some form, right? So the competitors have some sense that that they're actually um, doing something that's they're winning because they're good at it, or they're losing because I wasn't as good as the other person. Um, Interestingly enough, is those of you that play games know, a lot of times games have a random, people talk about RNG, random number generator, because the games make some events random. And good games do that because that gives you some variety. Nothing, things aren't totally predictable. But if you do that in an esport event, this is kind of like playing tennis, and every now and then the ball just doesn't bounce the same way. So if you have a game that has elements of randomness built in, then the esports leagues have to take that into account, right? And so the Dota Underlords card game has the card, like any other card game. The cards you draw are random, and so in order to make that a fair game, um, you have to first of all, the game has to be balanced, so that if I'm drawing a reasonable set of cards, there's not like one set of cards that will outperform everything else or beat everything else. And then of course the game format has to be I think the best analogy is baseball, in a very different way than Brandon's analogy, in the sense that there's we know that the World Series is played in series of seven, best out of seven. Um, and that's partially because you can make more money, but also partly because a single game doesn't necessarily tell you what the best team was. And so if a game has these randomness elements, the tournaments have to be organized to take that into account, and have best of three or best of five sequences, so that the random elements balance out, and every team has a fair shot at showing how good they are and what the best team is. So what all these things say is that I have to have the game design has to take into account that if a game um, is going to be esport ready, and that's actually a term that kind of bounces around the various Reddit forums. It has to take these things into account. It has to be designed to have all these elements in place, so it can be fun, both fun to play as a competitor and fun to watch. Then on the technical side, obviously there's a question of just how big a computer does the competitor need to actually be competitive. And you want the game to be good, you want it to look good, but at the same time you don't want to basically limit anyone except with whoever can pay a huge amount of money for a very fast machine. You don't want differences in graphics performance, for example, to determine who's going to be better at the game. So good esport titles tend to not necessarily be the ones that have the most demanding graphics environment, or at least they're playable when you scale the graphics back, so that performance is fair. Because in multiplayer games, server performance actually becomes a huge problem here. Because in a multiplayer game, let's say a multiplayer competitive game where you're basically competing, shooting at or whatever it may be, other players who are in the same game space. The Where I see, so if Chip is another player in my game, where I see Chip on my screen is determined by Chip's game sending his position or changes as he moves around to a server, which then turns around and tells me where he is. So we're talking about server update cycles. We're talking about 30 hertz, 60 hertz, 144 hertz servers, in the sense of how often can the server process the inbound information from all the players, turn around and send all that information back out in a timely fashion to all of the players. So, for example, there's a very popular game called Escape from Tarkov that's a lot of people are playing. It's not an esport title, but it's gotten a lot of attention, and it suffers terribly from their back-end servers being very poor, given the otherwise really good quality of the game. So a lot of experience, a lot of players have just very frustrating experiences where, their game, where one of the other avatars on screen just kind of randomly moves around very rapidly because the server got behind and didn't update the position properly for a long time. Sometimes it's referred to as netcode. There's a subset of the game engines that's basically designed to send out information to the server and the receive information server and update the game world based on that. And really good games in esport have custom tuned netcode that is very, very good and generates a very smooth performance in that aspect. Then sometimes overlooked, you can't. So all of these things are important for the game to function as a fun game. But for something to be an esport game, it has to have broadcast support. I have to make it easy for me as a producer to generate a view of the game that makes sense for the view for someone who's watching the game. Right, so if I'm playing the game, I can see maybe my teammates, but certainly the whole point of the game may be for me to find the members of the other team and engage in combat with them. But as a participant, I want to see all the players. I want to see where they are. I want to see their tactics. I want to see how they move around. So for a game to be esport capable, it has to have some sort of broadcast mode where I can, join the game not as a player but as a broadcaster, retrieve all the information that the server has, and show it in such a way that a color analyst, a play-by-play announcer, and yes, all those roles exist for esport. Can look at the overall game field and explain to the viewers what the players are doing. They can show them where the players are, what they think is going to happen, who's in a better position. All the things that you expect in a soccer match or in a football match or a basketball match. And so technically, both the performance and the sort of idea that I can broadcast out of a game without actually playing it has to be part of the equation. Let me close up with a couple of items that are closer to what's going to happen here at Ohio University. If you haven't heard the announcements, Ohio University is building a small esport facility. In fact, it's going to be in the basement of Scripps Hall, same building that the Grid Lab is in. Our school is going to be heavily involved in operating and overseeing that facility. So it's going to be, and it's an exciting time. As I said, we have an active group of students that are in various esports clubs, competing in various different types of games. So very exciting. From the perspective of universities, there are several different models as to how universities approach esport. One is obviously athletics. You could teach esport like another discipline in athletics. You could look at it as a student activity like the chess club. At Ohio University, the decision was made to place esport as part of academics. So yes, we will have teams that will be competing in a league that hasn't been fully announced yet, but there's some exhibition matches going on this semester. One of the things about esport is it really doesn't have to stop. The big in-person events, of course, are canceled, just like any other big sport event. But the smaller tournaments that were never meant to be, but to bring people together in the same place, they're still going on. In fact, tomorrow I think there's an administrators versus students League of Legends tournament. There's five, including our provost, by the way, five of our OU administrators are going to be playing against the League of Legends Esport club at the university sometime tomorrow, which would be good fun. But at Ohio University, we made the decision that esport ought to be part of academics. So we've done things that created an esport certificate that ties together some courses that would give students some sense of all the different aspects that I just talked about, and they get some exposure to all of those. So I think that's for us as an academic department, that's super exciting because it means that we'll actually have a great deal of say in shaping how this is going to work, how this is going to happen. Let me sort of finally touch on a subject that a lot of people try to not approach very much, but it is something we are going to have to be very mindful of and be very proactive in. Esport is very male dominated. In fact, I cannot think of, certainly not in a teams esport, I cannot think of a female player. There's female talent, female broadcasters, female color commentators, play-by-play announcers. A lot of female gamers are in those roles, but I cannot personally think of a top player as female. Most of the players are white or Asian. In terms of where the popularity of esport is, and so both various forms of harassment, including on the internet we would call trolling, unfortunately pretty common. Multiplayer games are known. Some of them are known for being very toxic in the player-to-player. Like the random pickup games can be very very toxic unless they're moderated, and that needs change. And I think with us having some academic umbrella around esport, it gives us both the opportunity but also the obligation of dealing with this one. We can't let this run rampant because it's unfortunately as much fun as esport is, as much as I want it to be a really popular aspect of gaming. It right now needs a bit of help to grow up. I'm not sure that I can put any other way. And if that happens, great. So I think that's that's kind of what I wanted to talk about. I said not the typical esport makes lots of money, which it does. It's a big industry, but I think there are lots of aspects around it that I wanted to touch on, and kind of go over a little bit. All right, let me see if we have any questions. Thoughts on gambling in esports? It's here already. I mean, you can bet on League of Legends or Dota 2 tournaments. There'll be lots and lots of places that'll happily take your credit card and your money if you want to bet on esport. It's here. That's here already. Right. We sort of put out one last call. Any other questions? By the way, if the question was, do I think it's right or wrong? I mean, that's there's a broader question here, right? As to but I think it's like any sort of sports gambling. Um, you know, people will bet on anything, and so esports not going to be. Oh, somebody asked about advice on pursuing an esport career. That's a tough one. Not sure that I have a terribly good answer. Um, the obviously other than being good, right? I mean, there's sort of that kind of stating the obvious. I think what is interesting, and it depends a little bit on the esport disciplines. I think what is interesting is that a lot of the traditional esport, I'm sorry, the traditional sports organizations are beginning to get seriously interested in esport. And what that says is that the more traditional sports management approaches begin to apply. Right? So I know a lot of soccer teams, European, especially some of the European ones, and some in the U.S. have started esport divisions. ESPN has an esport dedicated part of their website. So I think in many ways the uh, an esport career, either as a competitor or as someone in the industry, I think will look a lot more like a traditional sports management approach. How do you break into sports management in general? I think esport is not that different anymore, which is one of the reasons that the certificate we're putting out is a collaboration between our school and the Department of Sports Administration, which has a sports management program. So there's not a huge difference anymore, I don't think, at this point. Yeah. So if it's the if it's being part of the industry, um, the all you know all the so all the skill sets that go into sports management go into esport management as well. Whether on the broadcast side, a lot of the details are different. We still need to know production values. You need to understand, how to how to compose scenes and bring on talent and those sorts of things. Team management is very similar. With the difference that your team members may be living all over a country or indeed across the world, and managing a team is a bit different. So there tons of sort of differences in detail, but the overall management approach to an esport team is not dramatically different. So getting into that industry probably is pretty similar to what advice we would give to someone who wants to break into the regular athletics industry, and knowledge of team management, of event management in particular, are going to be super important, because that's what these organizations will be looking for. So, do you know how to put on an event, and organize teams, organize tournaments, those kinds of things.
Hans, do you mind if I add to that a little bit?
Yeah, please.
Yeah, I think that one of the things we talk about, or started to talk about in say network engineering, is our ability as IT technologists to be nimble. We're able to take on new technology, new understanding very quickly, and incorporate it into our environments. And I would think managing esports would be very similar. They're bringing on the same technologies to their environment, but they're going to need to be nimble. They're going to need to be able to change as that marketplace evolves.
Yeah, very, very, very good point. Very good point. All right. If there aren't any other questions, I'm going to switch to my single. First of all, let me say thank you to Brandon, to Chip. Thanks for being part of the panel. Thanks for everyone out there who's been viewing. Yeah, I think overall, from my perspective, and I will have an appropriate beverage and think about it some more, but from my perspective, I think we didn't do too badly. I think this is a good day. and I really, really appreciate everybody's participation. And I hope you had some fun. I hope you saw some interesting technological ways that we've found to stay in touch. And I hope everybody has a wonderful rest of the day. For our students, if you haven't signed up for one of those interview practices, there probably are some slots open. Get on it. And with that, I'm going to sign off here. Thanks again, everybody, for participating, for all our speakers and everyone else who made this happen.